Okay, my name is Hans, and I'm going to talk about Gigabit passive optical networks, briefly GPON. This is me. What I want to talk about is the traditional way of networks. We have switches, we have core switches, we have gateways and stuff. But in a larger environment, we're going to distribute our access switches, which is causing that we have maintenance for air conditioning, power supplies. So we need to provide a lot of places where we need to these maintenance and this air conditioning and stuff. Now we want to make it more easily with GPON, passive optical networks, because what we're going to do right now, we still have our gateway, we still have our core switch, but instead of all the distribution switches, we're going to use fiber optics, and we're going to connect the GPON switch with the actual access point. And in between, there's nothing. So it has less maintenance, but more reliability because of the passive cabling. Actually, the fiber optics is a passive device. So you don't need power, you don't need maintenance. We know GPON mainly from ISPs before, but now we're going to use it in our local network. So this was our scenario. This was a bungalow park, and we had some houses connected, and we need to redo all the cabling there. So we had the option now to go for copper or also use fiber to all the separate houses. Now we use GPON in this. So GPON, it's a point-to-multipoint technology. So we start from the OLT. The OLT is the GPON switch in the main building. And then with fiber splitters, we're going to split our fiber optics to each bungalow. Now, GPON is using wave division multiplexing, so WDM. So we can send downstream and upstream data over different wavelengths. And it's using fiber optics, typically single mode fiber, so we can go up to 20 kilometers, which is providing a high range, but still having less of passive cabling or passive equipment. So it was under the ITU regulation, so that's where you can find this. Now, my lab setup was a small GPON switch from Omada, which we call the OLT. And then I had two small access points, ONTs, which are connected by fiber. And in between, I had a small fiber splitter. It's not powered, it's just a passive device. One uplink, 4 downlinks. Now, over time, GPON has evolved, or actually, passive optical networks has evolved. So we had broadband PON, Ethernet PON, but now we're at GPON, and we're soon to have XPON, which can go to 10 gigabits. But do notice here, the downstream data is a lot higher compared to the upstream data. So the throughput for upstream is a lot less. So that's something to remember there. Why is that? Well, downstream data, what's happening, the OLT, or your GPON switch in the main center, it's broadcasting all the data on your fiber optic network. And in between, it's just a splitter. So it's broadcasting all the data over the network. With GPON, we can go up to 2.5 gigabits. So that's the maximum data rate there. With XPON, we can go to 10. Yeah? But this link is always active. So with GPON, the link is always active. And all the data frames we send over the network, we use the ONT ID, so the identifier for the frames. Each access point will pick up its own data frames. So ONT1 is picking up its data frame, but it will just be broadcast on the network. Right? Now, upstream is different, because for here, we're going to use time division multiple access, TDMA. So each ONT, each access point is giving time to send this data over the fiber optic network to the OLT, to the main switch. So for this reason, because the ONTs are not transmitting all the time, they just get a time slot. For this reason, our throughput is a lot less. Now, what's the problem here? We need a way to prioritize data or voice or video. Because for like these bungalow parks, we want to do IPTV, we want to do voice over Wi-Fi or voice over networks. So because GPON is not really Ethernet, it's another standards, there's another stack there. So we need to prioritize that. That's what we do. We're going to create a gem port. There's a gem port in there where we can say, okay, the prioritization, we can map a VLAN to a gem port. And this way, with my smartphone, I'm going to do internet access. With my IPTV, I'm going to do the VLAN for IPTV, and for voice, I'm going to have my voice VLAN. And each gem port has an identifier for that. So it's going from the end user device until the core switch. So there's an example of how we do this, just mapping gem ports to VLANs. Another thing, considerations about capacity. Because my GPON switch can have up to 128 access points. Now, it's only 2.5 gigabit there at the GPON switch, so splitting 2.5 gigabit into 128 connections, yeah, we're not going there. So if we calculate, that's like 20 megabits for each AP. It's like Wi-Fi is. It's broadcasting. It's everywhere. So are we really going to do it like that? So I limited my APs to like 32 APs per GPON connection. Upstream is even less because of TDMA. Now that's my capacity. Again, for quality of service, we have dynamic bandwidth allocation. So we can say, for this specific gem port, I'm going to fix that. I'm going to assure that we have this amount of capacity on my gem ports, on my GPON network. Or I can say for guest access, well, my phones can try to have the maximum, or assure and go to the maximum. So we assure a certain limit of bandwidth, but if you can do a burst. So we can prioritize some traffic. Another thing that's a problem, because power over fiber, it's not really there yet, so we need to power our APs. In our case, it was a bungalow park, so we took a storage room and we plugged in our AP there with a hardwire connection. So for this case, we do need a hardwire connection to power our access point. Again, about the splitter, because what's most important here is our fiber optic network. I use a fiber splitter 1-on-4, so 1 uplink, 4 downlinks. But in a bigger environment, we need fiber optic cable up to 20 kilometers. So we use calls and we run cables everywhere. But what's important, we need to connect, at some point, we need to connect these fiber optic cables, the terminators, to the coil. We can do it by mechanical splicing. So we have one connector, and we connect them together. The main thing is they need to be right in line, because if the fiber optic cable is not connecting right, you're going to have a problem. We have loss. With mechanical splicing, we put them together. It's like a sleeve. We close it, and there's shell in between. The problem with shell, it's a non-continuous link. So if you pull the cables really hard, you're going to break it. You have a lot of loss also, 0.5 dB loss with these kind of connectors. So that's not the best thing to do. Another way is doing fusion splicing. So this way, we're going to put the cables, we're going to put them together, and we're going to cleave them. So we're going to make sure they're straight, because otherwise, if they're not straight, again, we're going to have loss. But with fusion splicing, we're going to use an electric arc, and we're going to melt the fiber optics straight together. So we can be sure they have a good connection. With this electric arc, we're going to have a continuous link, because it's one cable. If you pull the cable, they're really strong. Once you bend them or you push them, they're going to break immediately, but if you pull them, they're quite strong. And you have a loss of 0.1 dB, so we have a really good connection, and not so much loss. Because it's exactly the loss that we have to be aware of. All these splitters, all these connectors, over time, over distance, you're going to lose power, you're going to lose dBs. Every splice is going to cause you some loss. But most important, and we do it all the time for everyone, check your fiber connectors. Make sure you clean your fiber connectors. Even if you have them brand new out of the plastic bag, clean them before you connect them. Even in traditional Wi-Fi, in traditional networking, clean them before you use them. And this is something I've seen people doing this all the time. They take their fiber connector and then they say, well, I don't see the link here. If you want to do that, take your phone, check the cable, put it to the camera, and then you will see the light for your fiber optic link, so you know the link is there. Because with a single mode of fiber, you're actually putting a tattoo on your eyelid, so please don't do that. People still do, so it's common to so we still see that. That's it about GPON. Thank you from Flemish Frequencies, and see you next year.